All right, welcome to the Explainer. Today, we're diving into one of the biggest hurdles in programming. How do you stop your code from spiraling into a giant, unmanageable mess? We're going to look at the tools Java gives us to create order, security, and sanity, starting with the very foundation, packages and access control. So let's kick things off with a feeling I'm sure every single developer knows all too well. You start a project. It's fresh, it's clean, it's simple. But then it grows. And that beautiful, simple start just descends into total and utter chaos. I mean, when you've only got a handful of files, it's no big deal, right? But what happens when that project explodes into hundreds or even thousands of different classes? If you don't have a system, it becomes this digital labyrinth. Just finding what you need is a nightmare, and you're constantly terrified that changing one thing will break something else. And look, this isn't just about being messy. This disorganization causes real project-killing problems. You get naming conflicts, where two different people both create a class and call it something generic like utils. It makes finding code feel like a treasure hunt with no map. And worst of all, it leaves your application's most critical parts totally exposed, fragile, and just waiting to be broken by accident. So, how do we fight back? How do we bring order to this chaos? Well, the first and most fundamental tool we're going to grab from our toolbox is the Java package. So what exactly is a package? Honestly, the best way to think about it is like a folder on your computer, or maybe a super specific, clearly labeled section in a library. It's a way to group related code together. And just by doing that, you immediately solve that naming conflict problem we just talked about, and you start laying the groundwork for actually controlling who gets to touch your code. And the best part? Using them is wonderfully simple. It's kind of like a three-step dance. First, you declare the package name right at the very top of your Java file. Second, and this is super important, you have to make sure your actual folder structure on your computer mirrors that package name. And finally, whenever you want to use a class from another package, you just import it. That's it. Now, here's the really cool part. Whether you knew it or not, you've been using packages this entire time. Every single time you've used an array list from java.util, or handled a file with java.io, or built a little user interface with java.xx.swing, you've been tapping into the power of Java's own incredibly well-organized package system. Okay, so our code is now all neatly filed away in different packages. We're done, right? Well, not so fast. That's only half the battle. Just because your books are on the right shelf in the library doesn't mean anyone should be able to just walk in and rewrite them. Now we need to control who gets the keys. To do this, Java gives us 4 things called access modifiers. And honestly, the absolute best way to think of them is like different security keycards for your code. They decide exactly who gets to see and use your classes, your methods, and your variables. This is the bedrock of building a secure and reliable application. First up, we've got public. This is the master key, the all-access pass. When you mark something as public, it's a complete free-for-all. Any class, in any package, anywhere in your entire project can see it and use it. This is what you want for the main front doors of your application, the public API you want everyone to use. Then, on the complete opposite end of the spectrum, you've got private. This is Fort Knox, maximum security lockdown. A private method or variable can only be accessed from inside the exact same class where it was created. Nothing outside that class even knows it exists. This is your default for internal data. It's the heart of protecting your code. Now we get to the interesting one in the middle, protected. This one's a bit special. It's got a dual purpose. Code that's protected is visible to everything else inside its own package. But, and here's its superpower, it's also visible to any subclasses, even if those subclasses live in a totally different package. You can think of it as a key for close family members. So what happens if you just don't type a modifier at all? Is that a mistake? Nope. That's the default access level, which most people call package private. This means your code is visible to all the other classes in the very same package, but it's completely invisible to the outside world. It's perfect for helper classes that need to work together as a tight-knit team. And check this out. This code snippet shows it perfectly. We've got class A and a package called pack. Notice there's no modifier like public or private on the class itself, so it's package private. Now, over in a completely different package called mypack, class B tries to use it. And bam! The compiler slams on the brakes. Compile time error. Why? Because from B's perspective, outside the pack package, class A might as well not even exist. So we have packages for organization and access modifiers for security. But why do we care so much? What's the big payoff? Well, when you put these two ideas together, they enable one of the absolute pillars of object-oriented programming. And that concept is called encapsulation. It sounds a little academic, but the idea is actually beautiful and simple. It's all about bundling your data, the what it is, and the methods that work on that data, the what it does, into one single self-contained unit. And, crucially, it's about hiding all the messy internal details from the outside world.
So how do you actually do it? Well, there's a really powerful rule of thumb that'll get you most of the way there. Make your data fields, your variables, private. Then you provide public methods, you've probably heard of them as getters and setters, that act as a controlled, protected gateway to that hidden data. And this isn't just about being tidy for the sake of it. This gives you absolute control. You can put validation logic in your public methods to make sure the data is always correct. You protect your objects from being put into a broken state. And get this, it gives you the flexibility to completely change how things work on the inside without breaking a single piece of code that uses your class on the outside.
Ultimately, all of these concepts, packages, and access control are about making a critical leap. It's the leap from just writing code that happens to work to actually engineering professional, reliable software that's built to last. Because when you combine the clean organization you get from packages with the intentional safety you get from access modifiers, you end up with code that is just plain better. It's easier to maintain, it's safe to reuse in other projects, and it's far more robust. This is the foundation that lets a tiny project grow into a huge, stable application. So, the real takeaway is this. By mastering these fundamentals, you're not just writing lines of code anymore. You're being an architect. You're engineering software. Now that you have the blueprint for creating these clean, secure, and reliable components, the only real question is, what amazing thing are you going to build next?